This is problem 7-91 from section 7.1.6. Find the exact values of the angles that are solutions to the equation sine of theta equals 0.5. Express your solutions in radians. So what we need to do is find the angle where its sine is at 1/2 or 0.5 and make sure we answer that in radians. Okay? So let's first draw a triangle, possibly. Now we know sine is positive, so I know it's going to be in the upper quadrant, upper one or two quadrants. So let's start with this. And I'm going to label the side, the sine, which is the height of my hypotenuse, of my triangle. I'm going to label it 1/2. You can write 0.5, I'm just going to say 1/2. And I know my radius is one, I'm going to assume that it's a 1. Think about the screamer, it was 100 degrees, or 100 feet around, so shrink it down, it's just a 1. So what we want to know is what is this angle and what is its degree, what is it in radians. Okay, so what first might be helpful is to figure out, well, how much is this side? Okay, so if we know that, we can figure that out. Okay, so let's use our Pythagorean identity, which is sine squared, or sine of theta squared, plus cosine of theta squared equals 1. Or 1 squared, but 1 squared is 1. Okay, so sine of theta was 1/2, and we square it, plus cosine of theta is my horizontal distance I don't know, which equals 1. Okay, so if I take 1/2 and I square it, I get 1/4, plus cosine of theta squared equals 1. I subtract that, I'm going to get cosine of theta squared equals 3/4. Take the square root of both sides, so I'm just going to get cosine of theta now equals square root of 3 divided by 2. Okay, so now the cosine is going to be radical 3 over 2, or my horizontal distance, radical 3 over 2. Now, these relationships might not come to mind, might not look as familiar, possibly. You're like, what, is that 30, 60, 90, 45, 45, 90? It doesn't look familiar. What if we multiplied all of these numbers times 2? And we get a different value. Now our relationship among the angles is going to be a 2. This is going to be a 2. This is just going to be radical 3. And this is going to be 1. 1, radical 3, and 2. Does that sound any more familiar now? Okay, that should remind you of a 30, 60, 90 triangle. Okay, and I know 1 is my smallest value among these three numbers. 1 is the smallest, so that means this is the smallest angle of 30, 60, and 90. So I know this is really 30-degree angle. Okay, so now I know the angle was 30 degrees, but how do we express that in radians? Okay, so think about my circle. If I split up my top half of the circle, if I do 30 here, and I have them all be equally 30, that doesn't look like 30, but it's supposed to be. Okay, we can just split them up into all 30 equal pieces. I'm going to have 6 pieces total. So this 30 degrees right here is pi over 6, or half of my circle, which is worth pi, and then divided into 6 pieces. So 30 degrees is my angle, but I want it to be pi over 6 is one of my possible values if sine is worth 1/2. Okay? So let's see if there's another one now. So we have that angle, and I'm going to clear out my circle here. Okay, so we know something about circles. We were talking about this. Let me redraw my little 30-degree angle in. Okay, so I have this guy. I know this is 1/2. Now we talked about this. If you were a rider over here, where would you also have the height of 1/2? Now this time we only want positive 1/2, not positive or negative. Okay, we want to have a positive height. So where else would you have a height of 1/2? Well, if I know this is 30 degrees, we know that there's going to be one exactly on the other side of this circle. So 30 degrees this direction. Okay? So we want to know what is that angle just from here to there. So I'm going to take 180 minus the reference angle of 30, which tells me this angle is 150 degrees. Or again, we want to know in radians. Okay, so if I break this up into 6 equal pieces on the top, because each of them are worth 30, this right here is which piece of that, of those 6. This is 1, 2, 3, 4. This is the 5th piece. So 150 degrees is another angle, and that's going to equal 5 pi over 6. Okay, because that was my 5th little chunk of the circle, if I count them again. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, or just pi. Okay, so we want to answer in radians. Now, let's think about this if we're on the screamer. So we have a height of 1/2 either right here or right here. Now, what if you stay on the ride again? Are you going to ever hit that 1/2 height? Yes, you're going to keep hitting it every single time you hit this spot and this spot. Okay, you're going to keep going every cycle, or every time you're on this screamer ride again, you're going to get the same height. So we could write this. Those are my 2 values that work, but it really could be pi over 6 plus 2 pi is how many radians we go around if we go one time around, right? So I could do it plus 2 pi. So I stay on the ride one more time, I'm going to hit that height again. What if I stay on for 2 more times? Or for 3 more times? Or 4 more times? Or how about like n number of cycles? Okay? So we can represent this not only in our one time around, but this would be for what kind of you stay on the ride forever. Right? You keep hitting it every time you're at that height, no matter how many times you've been on it. Same thing for this 5 pi over 6. If I stay on the ride for another cycle, I'm going to get that same height, or for 2 more cycles, 3 more cycles, or n number of cycles. Okay? So this is really, the book answer is just these 2 in the green, not just these 2, but technically I can keep staying on my screamer, and I can get like an infinite number of times where my sign would be 1/2, but it doesn't totally specify if it just wants it on one time around, so technically it could keep happening many, many times. Okay, I wanted to show you another way to solve problem 7-91. So you're given the sine of theta is worth 1/2. We want to find what angle was that at, and we want to say that in radians, though. Okay, so we went about finding what was the cosine, and then found out what the angle was through which relationship of triangles. But something that is probably more appealing to you is, how do I find this angle, this missing angle? Well, I'm going to do the inverse. Sine inverse of 0.5 equals theta. Right, equals my angle. Now what we need to make sure we do is that you're in that you are in degrees, because what we're going to do is get out our theta, or our angle, in degrees, and then we have to convert that. Okay, so make sure you're in degrees in your calculator, because you're switching back and forth. So I get this. This is going to equal 30 degrees. So boom, there's your angle right there. So now I know, here's my 30 degrees. Okay, so I know what angle I'm at. Now I just needed to convert 30 degrees into radians, which is going to be the same thing. So if I cut this in half, and that's pi radians, I'm going to cut this into, everything's going to be 30 degrees. Okay, so I have a total of 6 things, and this is my first 6th of my half, which was worth pi. Okay, so 6 of pi, 1/6 of pi, is worth 30 degrees. So we do the same thing for the other side. We know it reflected over here, so we're still going to get the same 5 pi over 6 value. But I just wanted to show you another way, which you guys will probably think of this way anyway, but just doing the inverse of sine rather than finding the actual cosine of the angle and then finding the angle itself. So you can kind of do it either way, but just wanted to show you this other shortcut.